Hello class, welcome to Geometry Lesson 7.5, which is all about proportions in triangles. By the end of this lesson, you should be able to find the lengths of segments using proportional relationships in triangles resulting from parallel lines. So that means some important information to remember would be our angle relationships, okay? So thinking back to our dance transversal in chapter 2. So an example of, remember, like vertical angles would be angle 1 and angle 3, and vertical angles are always congruent. An example of alternate interior angles would be angle 3 and angle 5, and alternate interior angles are always congruent. Alternate exterior would be angle 1 and angle 7. Alternate exterior angles are also congruent. And then we also had our consecutive interior angles. So that would be angle 4 and angle 5. And those are not congruent, but they are supplementary. Okay, so you're going to be working with parallel lines. And anytime in geometry that you work with parallel lines, you want to think about these angle relationships. All right, so let's start with example 1 where we explore the proportions from parallel lines. So if we start with this triangle JLN over here on the right, and we know that LN, so this entire thing, is 9.6, what are LM and MN? And then are the sides divided into proportional segments? Explain. So first, we want to figure out how the big triangle JLN, and triangle KLM, so that smaller triangle. So the whole triangle and then that little like blue triangle. We want to know how they're related. Both of those triangles share angle L, right? It appears in both the blue triangle and in our entire purple triangle. So that angle didn't change. And then if we think about angle LJN, so this angle down here, that would have to be congruent to angle LKM by the corresponding angles theorem. That's the one that I forgot on the last page, so sorry. But remember corresponding angles. So if I have two parallel lines, 3 and 5 or something, those would be corresponding and they are congruent. Okay, so angle LJN is congruent to angle LKM. Therefore, those two triangles, are similar by angle-angle similarity. So then I can write a proportion relating our corresponding sides. So those corresponding sides that I know is I could say LK and LJ. So those are the corresponding sides, right? LK is our small triangle, and LJ, oops, I meant to pick up the purple one. LJ is the corresponding side on the bigger triangle. So I could say LK over LJ equals, and then I would say LM over LN. Once I've set that up, I can start plugging numbers in. So I know LK equals 3 because the picture tells me that right up here. And then I know that LJ would be 8 because it would be 5 plus 3 because it's this entire side. So I would say 3 over 8 equals LM, I don't know. And then LN, the entire distance, is 9.6. They told us that in the directions. So then I can cross multiply and divide. So 3 times 9.6 divided by 8 leaves me with 3.6 for LM. And then I want to figure out what MN is. So I know that MN, this last side right here, would have to be the whole side minus LM, the side that I just solved for. So I can say MN equals the whole side, 9.6, minus that smaller side we solved for, 3.6. So 9.6 minus 3.6 tells me that MN equals 6. And now we know what all of those measures are. But the question, if we go back up, is, are the sides divided into proportional segments? So let's take a look at that. Our last step would be to say LK over KJ. So that is taking both of these sides. So 3 and then separately the 5. And I want to know if that ratio, 3 over 5, equals the same as LM over MN. If it does, then I know that these are proportional. So LK equals 3, KJ equals 5. If I divide that, I get 0.6. And then if I have LM over MN, that's 3.6 divided by 6, which is 0.6. Since both of those equal 3, words are tough. I feel like I'm saying that every video this year. Sorry, guys. It equals 0.6. Both of them equal that. So we know that segment KM divides segment LJ and segment LN proportionally. So that line going through the triangle divides the sides in a proportional fashion. So then here is a theorem, Theorem 7.6, called the triangle midsegment theorem. If a segment joins the midpoints of two sides of a triangle, so that means DG would be equal to EG, and EH would be converted to FH. If a segment does that, joins the two midpoints on the sides of a triangle, then the segment is parallel to the third side and is half as long. So this kind of ties back to the triangle midsegment theorem from the trapezoid midsegment theorem from last chapter. So we would know that that segment would be equal to 1/2 DF. So it's just a little different than the trapezoid, but pretty similar. All right, example 2, if we want to use the Sidesplitter theorem. Okay, so the Sidesplitter theorem, that is when you are trying to find different side lengths. So we have what is the value of x in a triangle PQR. So you can see we have x listed in 2 different spots. Okay, and if we look according to our picture, line or segment ST is parallel to segment PR, which that is helpful because then we know we have some similar triangles, and therefore we can also say we can set up a proportion and solve. So PS over SQ, so PS over SQ should equal RT over TQ. Then if I add everything together, PS I know is x plus 2. SQ would be 4 plus 12, which is 16. And then for the other side, I know that RT is equal to x, and then QV I have 9 plus 3, which is 12. So now that I've plugged that in, I can solve. So I can cross multiply if I would like, and I can say, it looks like they went the common denominator method, which is fine. I think most of you would feel more comfortable if we said something like this, where we cross multiplied, so this would become 12 times x plus 2 equals 16x. So 12x plus 24 equals 16x. Then if you subtract 12x from both sides, you have 24 equals 4x, or x equals 6. So that's 2 different ways that you can solve this problem. I think you guys will probably prefer this method, but I could be wrong. You're welcome to solve either way. So you would end up with x equals 6, and the problem was asking for you to find the value of x. So we know that we are done. Oops, too far. All right, then this basically just says the opposite of the last theorem that we talked about. So if we already know that we have parallel lines that intersect two transversals, then the segments intercepted on the transversals are proportional. So we have three parallel lines. You can see that line L, M, and N. And we have two transversals. And those transversals create some proportional relationships. So I know that AB and BC have to be proportional to the same relationship of DE and EF. Okay? Because since these lines are parallel, they should be the same distance along these transversals. So you're going to really want to try to ingrain this image in your mind on how to set up these proportions. And then we have a word problem where we want to find a length. A reflecting pool is separated by walkways parallel to Lincoln Street and Jefferson Street. Okay, so we have these walkways, and they are parallel to each other. The city wants to add additional tiling around the pool. How much tiling does X feet represent? So if we're looking at this drawing and we want to solve for X, I see that I should be able to set up a proportion. So I can say, okay, X feet is going to line up with 24 feet, and 60 feet should line up with the 72 feet. So I can say X over 60, since they're on the same side, equals 24 over 72. And if I solve that and multiply 60 to the other side, I would end up with something that looks like that, and that would ultimately, when I plug it in, I should get X equals 20. So my answer would be 20 feet. Okay. Then, why don't you guys take that same problem, but this time I want you to solve for Y. Good luck. All right, so hopefully you set up your proportion 24 over 60, and then Y over 72, cross multiplied and divided, and ended up at Y equals 28.8. If you did not get that answer, maybe you said Y equals 10. That means that you set up your proportion incorrectly. If you have questions, please be sure to ask for some help. All right, example 4, investigate proportionality with an angle bisector. Okay, so we have in triangle KLM, segment NL bisects angle KLM. So this line right here is cutting that larger angle in half. Okay, compare the ratios between KN and MN, as well as KL and ML. Okay, so we're going to compare those. If we start with the purple lines first, KN over MN would be 10.5 over 7.5, which if I divide that, I get 1.4. And then if I look at the blue sides and I said KL, which is 14, over ML, which is 10, 14 divided by 10 is 1.4. So these ratios are equal. However, if we were to compare NL to NL, however long NL is, it doesn't really matter, because anything divided by NL, or anything divided by itself, anything divided by itself, any fraction becomes 1, right? And so we would have two sides that were proportional, but if we compared that third side of the triangle, that side does not equal 1.4. The ratio of these sides equals 1. So that means that these two triangles are not similar. Okay, so you need to always check all three sides, especially, well, you need to check all three sides if you don't have an angle that you can use. Okay, so here's the theorem that kind of discusses that further. So if we have a ray bisects an angle of a triangle and it divides the opposite side into two segments that are proportional to the other two sides of the triangle. So that is always true. So when we did the UX and WX would be proportional to UV and WV. If you have an angle bisector, that is always true. What's not true is that those two triangles will always be similar. It can happen, just not often. Okay, then example 5, we're going to use the triangle angle bisector theorem. So if we have this given triangle, we want to know what are the values of AD and DC. So we know that AD is X units long. We know AC is grand total of 13. And we want to figure out what those measures are. So we know BD bisects angle ABC. You can tell by the drawing. We have the congruency symbols. And we want to use the triangle angle bisector theorem to write a proportion. So since we have that angle bisector, I know my opposite sides, if I set up a proportion AD over CD, that should be the equal proportion to AB over CB. And you might be wondering, how do I know if it's AB over CB or CB over AB? But if you look, AD and AB are kind of part of the same triangle. So it makes sense to group those two together. Okay. Then all we have to do is plug in numbers. So I know AD is X units and CD is whatever 13 minus X. We don't know what it is. We're not going to introduce another variable. Some of you are going to be tempted to just say Y units because we don't know what it is. But we can be more specific than that. We can say CD is going to be 13 minus X units. And then I'd say equals 10 over 16. Then if I cross multiply, 16 times X is just 16X. Distribute this 10 to everything. So 13 times 10 is 130 minus 10X. And then if I add 10X to both sides, I have 26 equals 130. And divide both sides by 26, I get X equals 5. So that means that AD equals 5 and CD would be 13 minus 5 or 8 units. Okay, why don't you go ahead and try to find the value of X and then use that to find the value of GH and GK. Good luck. All right, hopefully for this problem you got that X equals 9. All of the purple work shows you how I got to that answer. And then hopefully for GH you ended up with 30 units and GK you ended up with 20 units. If you have any questions at all, please be sure to reach out for some help. And here is the last thing for you. It's the concept summary from this lesson. If you would like to take a screenshot of it, go ahead. And I hope you guys have a great day.